Welcome back. Please to join me back to learn about the embedded system design on ARM Cortex M4. So far, I'm sure you were covering all the previous session and you got yourselves familiarized with using different peripherals and that connected to the different bus systems in the microcontroller and also the associated registers with it, and you're enjoying programming. Today we are on day 25 and we're going to learn the demo part of I2C. Before that, you will be also learning to code the burst read and burst write and also the interfacing with the ADXL, the accelerometer. I have connected the hardware, so please to connect the hardware handy. My microcontroller, and that's the accelerometer, so that's connected with the logic analyzer. As you can see, that's my logic analyzer. So everything it's ready. I will show you line by line when we interface. I'm going to give a small recap of what we learned so far with the I2C. It's going to be really fast because I covered in elaborate with the last two sessions. And today you're going to learn to code about I2C burst read, burst write, and for interfacing with ADXL345. Before doing that, I would like to introduce myself. I'm representing A2DG. It's a startup by Anbukaras brothers Alex and myself Arul in 2023. Both of us gathered over 20 plus years industry experience, and we would really like to put it out there to help you all so that you would be beneficial from it and you can also be a better professional. And our mission is to convey to at least 100,000 future professionals through our online course medium. And the good thing about it is you can learn from anywhere, wherever you are. It doesn't matter, you can learn from everywhere. So that's really good about it. A little bit about me. I'm Arul P. Anbukarasu. You can call me as Arul or API, as persistent as I would like to be. I'd like to share my knowledge and experience to you all. I have 20 plus years experience of working in various countries, in Australia, Italy, Singapore, and in India, majoring in concentrating on all these industries: renewable energy sector, solar and wind power conversion, power systems that associated with lead acid batteries, network embedded systems that's linked with ATMs, TCRs, and POS, banking automation systems, and smart parking operations. And my expertise lies on these three: embedded systems, VLSI, and project management. I have a small announcement to make. I have categorized into two different categories as YouTube viewers, as you know, and the internship professionals. You've been hearing all about it. All the videos will be loaded to A2DG channel. So if you want to get a free certificate, you have to watch at least 28 YouTube's videos. And at the end of each and every YouTube video, there will be an attendance link. Click on that and fill all your details and send it across to us, and that will automatically get you to a e-certificate. But part of the YouTube regulations, all the videos can't live there forever, so it has to be, unfortunately, to be removed after 2 or 3 days. In case if you want to recap, unfortunately you will miss out. So that's why I strongly advise you and please recommend you to join our internship program, which will acquire you the main internship certificate. That is worth a lot, because when you land into that queue of interview and also the first job, the senior engineers will value those 30 days that you travel through will be a lot worth of it, because you already went through the hardware, you learned all the fundamentals, and also you worked on major projects itself during these 30 days. So they don't have to teach you much. You will start inputting yourselves into the team and you will be really worthwhile in the team. Not only that, you will get a separate login to access to our LMS portal to go through each and every session. At the end of the session, you can click on the complete button that will act as your attendance for that session. Not only that, on top of that, you will get unlimited access to all our PDF materials, the course materials, the source codes, the data sheets, the reference manuals, everything that's related to this course. And also unlimited access to all the course videos. In case if you want to pause and if you are wanting to do something else, you can come back and watch it again, or if you want to recap, if you want to go 5-10 days before, you can also do that. So it's all yours to keep. In case if you got stuck, please to contact our backend team. They would be able to help you to make your journey smoother and make you learning further along. Can we get into learn to communicate through this I2C that we saw in the last two sessions in part 2 and part 1? Today going to be a little bit stretchy because we're going to write 3 different functions and that's a bit lengthy session. So I won't waste much time about recapping much, so we can go directly into the IDE. These are all the things that we learned, so I'll just quickly run through that so your brain can sink into what we learned so far. Timing diagrams of I2C and writing to a slave, reading from the slave, and how the STM32 linked with the I2C bus. And this is the interface bit that we're going to interface with the accelerometer ADXL345, which is connected and ready to be shown to you through pulse view with along the logic analyzer. And these are all the steps. You already written the program for I2C initialization. And also you used serial clock control settings, CR2, control register 2, and clock control register. And also you calculated the CCR to load that into the CCR register by this example as 80. And these are all the steps I copied across. In the first session you learned about writing a function for I2C initialization. Voila, get in. Part 3 continues from here. So we're going to interface that with the ATM32. As you can see from the diagram, we're going to use PB8 and 9. So the PB8 is connected to the SCL of the ADXL, and the serial data is connected to the PB9, which will be this pin. And also you need to connect the ground and VCC, which can be taken from anywhere in this pin. So I used the 3rd pin for the 5 volts and use the 10th pin for this as ground. So that's how the connection is completed. And then you can connect your channel of the logic analyzer. I connected to port A pin 5, so I'll show you in the program. Then you learned about using different macros. This is the clock control register, CCR register. And then we also define the rise time for 17 using these 5 registers, 5 to 0. And then the control register 2 to enable the peripheral clock. We also use this macros. And the control register 1 you saw one by one to first with the start generation, and then the peripheral enable, and then the acknowledge enable, and then you stop sending the stop bit. Also you learn the status register 1 by starting with the start bit and the TXC RNE bit and the address bit, and then finally with the byte transfer bit, as you already learned. And then the SR2 register for the busy status, you use that. And then I went through quickly and defined all of this in the other session with the device ID, the data format, the power control, and data start address and the device address, and we measuring the 4G range. So you need to be in 0, 1. So we're going to measure 4G. And then the reset and set measure. I'll also hide myself so I can see the full screen, sorry. Then we went to learn and write line by line about the I2C byte read. That was the last session. So in this session you're going to learn about all of this, the burst read, I2C burst read. So you need to follow basically all these steps, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 steps. And then you're going to learn about to write I2C burst. So the only changes will be in this after send memory address you need to set a timer, and that will be the only difference, but the rest all will be the same. And then you're going to interface that with the ADXL 345, so you need to read that value, so you're going to write a small function to that, and then you need to write to it using this function, and then you need to initialize that using this function. and then the ADXL read address program by using this function, and then the main program you need to call everything in, and you're going to learn all of that line by line in this session. So before that, I'll give you a short break. So if you like, please go and enjoy that break, and when you come back, I'll take you to the IDE and I will show you line by line to write those functions and take it from there. So I'll catch you shortly.